Hey everyone, I'm Abhijit and today I'm here on behalf of Team Debrief to give you a short description or the working of a prototype on the problem statement, the green transformation of boats to achieve net zero carbon emissions. Our problem statement code is AK1136 and our theme name is Clean and Green Technology. So now in the upcoming slides, I'm going to be telling you about our prototype, working and description. Looking forward to meet you in the next slides. So now I'm going to be giving you a very short overview of our idea and approach. So basically our approach consists of the process which is direct air capture, which is a developing technology for removing carbon dioxide from the atmosphere or from low carbon dioxide containing sources. The idea is to capture the harmful carbon dioxide which comes out from the SEPS engine and use it to form some other useful resources. Atmospheric carbon dioxide is made to react with lime water, which is a solution of calcium hydroxide, CaOH whole twice, to form a white precipitate which appears milky for the signs of identification of calcium carbonate, CaCO3. Now, I'm going to be telling you about the technology stack that we have used here. The calcium hydroxide saturated aqueous solution had the highest absorption rate and capture ratio among the 6 investigated absorbents. The calcium carbonate obtained is strongly heated until it undergoes the thermal decomposition to form calcium oxide and carbon dioxide. The carbon dioxide obtained can further be stored and used to form various byproducts. So as you can see at the top right corner, we have the structure of our prototype. This structure is cylindrical in the middle and conical at the ends. So now you can see I'm going to be giving you a very short overview of how this prototype works. So from the left end, there's an intake of atmospheric air, and you know that carbon dioxide is one of the major constituent gas of atmospheric air. When this air is passed through the middle section, there's a solution of calcium hydroxide, and the reaction between calcium hydroxide and carbon dioxide happens here. When there's a result this result in the formation of precipitates of calcium carbonate, which crystallize at the end, and it settles down and it comes in this bottom chamber, as you can see here. Now, the remaining air, as you know, that some part of this air, the carbon dioxide, is basically trapped, and this air is purified to some extent. Now, what happened is the calcium carbonate crystals that we have obtained, they are made to undergo through the thermal decomposition by heating them. Now, the thermal decomposition of calcium carbonate results in the formation of calcium oxide and carbon dioxide. So our ultimate motive was that there's a capture of the carbon dioxide from the atmospheric air, and we have captured that carbon dioxide here. So we have the trapped form of carbon dioxide which can be used for further uses. Now, I'm going to be telling one of our uses that we are making the approach for. This carbon dioxide is made to react with hydrogen gas, which can be obtained with the electrolysis of water, you can say. And this reaction can lead to the formation of methanol or many other carbon products, which is methanol is basically one of the efficient fuel. So this was the brief idea of how we are going to use our prototype for. So now I'm going to be telling you about our use cases here. The calcium carbonate form is a precipitate and it is not soluble in water. So this is the reason, one of the major reasons why we have used calcium hydroxide solution, as the calcium carbonate is a precipitate and which can be stored for further uses. The next step is decomposing water to create a hydrogen gas using renewable energy, which then bonds with the calcium carbon dioxide on the surface of the catalyst to create methanol. Now I'm going to be telling you about the dependencies and showstopper here. Methanol is a cost-effective liquid fuel alternative for power generation, particularly in remote regions, which uses diesels and are not situated near gas pipelines. It is a cleaner burning fuel as it doesn't release harmful gases on combustion. We are not only reducing the amount of the carbon dioxide from the environment, but we are also using it for making some alternative renewable and clean fuel. Thank you very much. This was our use cases and dependencies.